Alrighty guys, here we go. Number 35. It says label each table as proportional or non-proportional situation. So this is miles run in how many minutes. So let's check and see if we can figure out what the rule is here. How do we get from 3 to 24? Well, that's multiplied by 8. 3 times 8 is 24. So this was times 8. So let's check here. Is 6 times 8 48? Yep, that's times 8. 9 times 8 is 72. And 12 times 8 is 96. So this one is proportional because it is this. The rule is the same all the way across, and there's no addition. It's just straight multiplying. So this is proportional. What would my formula for this be? Just a little bonus. In fact, I'm not going to tell you. Here's what we're going to do. By Friday, 5 more gobbler dollars. If you can tell me, if you can show me in y equals kx format of the ones that are proportional here, if you can write out the formulas on your study guide and show it to me, I'll give you another 5 gobbler dollars. All right. Weekly pay. He makes 10 bucks and worked 10 hours. Here he made 20 bucks and worked 5 hours. Here he paid 25. That is not proportional. There is no rhyme or reason to how any of that worked. If it was flipped around the other way, it would work. But that, nope, not happening. Because this is times 1 and this is divided by 4, and I don't even know what that is, and that's divided by 25. Each value in that table is different, so it's not proportional. All right, so let's look at this one. Minutes used in your cell phone charge. Okay, so 25. You use 25 minutes, you're charged $20. You use 50 minutes, you're charged $40. Okay, so that's doubled. Okay, so let's jump over here to 100. 50 to 100 is doubled, but 40 to 65, that's not doubled, so that one's going to be non-proportional. Again, I don't have a single multiplication that I can do from one to the next. Like I could up here, everything was 3 times 8. 6 times 8 was 48. 9 times 8 was 72. 12 times 8 was 96. I don't have that rule for either one of these two tables. That's why it's non-proportional. So let's try this one. He drove 60 miles in 1 hour. Okay, that's divided by 60. 120 divided by 60 is 2. 180 divided by 20 is 3. So this is divided by 20. My rule is divided by 20. Divided by 20. Divided by 20. So yeah, that works. So that one is proportional. The other way I know it's proportional is this is my miles per hour. So it's consistent. In 1 hour he drove 60, in 2 he drove 120, in 3 he drove 180. So that one's proportional. Okay, number 36. The number of chores you do at home is proportional to the amount of allowance you get each week. Which of the following statements is true? Okay, if you do twice as many chores, you earn twice as much money. Possibly. If you do no chores, you still receive some money. Not if it's proportional to the amount of allowance. The number of chores is proportional to the amount of allowance. So we're going to cross off B. Don't get something for nothing. If you do half your chores, you receive twice as much money. I wish I could do half the work and get double my pay. Nope, that doesn't work. And the amount of your allowance divided by the number of chores you do varies each week. The amount of your allowance divided by the number of chores, that's not right either. So it looks like if you do twice as many chores, you earn twice as much money. Would indeed show a proportional relationship between the amount of work you do and the amount of money you get. Okay? All right, 37. Identify the proportional relationships. What do I know about a graph with a proportional relationship? I know it's a straight line. And I know it's a straight line that goes through the origin. So what I do is I just go and make a point at the origin. Does that line pass through it? If the line passes through it, then it's a proportional relationship. It doesn't pass through at A, it does pass through at B, and it does pass through at C. Okay? Alright, number 38. Mr. Reciprocal started walking as his New Year's resolution. He calculated that he can walk a half a mile in a quarter of an hour. What's his walking rate per hour? Well, let's break out the notebook paper. All right. So he knows he can do a half a mile in 1/4 of an hour. Oops, before 1/4 of an hour. They want to know how many miles can he walk in 1 hour. So with this one, I have two different ways I can do it. I can cross multiply, which gives me 1/4 m equals 1/2. And then I multiply this side by 4/1, and those cancel. Multiply this side by 4/1, and I wind up with m equals 4/2, which is 2. Or I can look at this and say, well, I have a quarter of an hour, so I have a half a mile in 1/4 of an hour equals how many miles in 1 hour. Okay, well, how do I get from 1/4 of an hour to 1 hour? I multiply by 4, right? So to get from here to here, I multiply by 4. So if I have 4 halves, then I have 2 miles. Okay, either way, I came up with 2 miles per hour. Okay, which is answer number D. And this was number 38. Alright, number 39. Pack and Ship charges customers $0.75 for every 5/8 of a pound that a package weighs. Wait, in pounds, how heavy is a package that ships for $1? Okay, so this is going to be set up similar to number 38. So let's look at number 39. So I have $0.75 for every 5/8 of a pound. What they want to know is if my package is $1, then how many pounds is my package? Okay, so that's another one where I'm going to say, I'm going to cross multiply. So I have 3/4 P equals 1 times 5/8 is 5/8. And then I have to get that P by itself, which means I have to multiply this by its reciprocal. So I have to multiply this times 4/3. And those cancel. If I multiply this side by 4/3, I have to multiply this side by 4/3. And I see an opportunity to do some cross-canceling. 4 goes into 4 one time, and 4 goes into 8 two times. So I'm left with P equals 5 times 1 is 5, and 2 times 3 is 6. Okay? So the package that ships for $1, it weighs 5/6 of a pound. All right, number 40. A recipe calls for 2.25 cups of flour to make 6 cupcakes. How much flour is needed to bake 15 cupcakes? Well, I'm just going to set this up as a proportion. So this is number 40. I have 2.5 cups to make 6 cupcakes. I'm going to convert that to a decimal just to make it easier for me in the proportion. So I have 2.5 of flour for 6 cupcakes. Okay? They want to know how much flour do I need to bake 15 cupcakes. So I'm going to cross multiply, grab my calculator. So I have 2.5 times 15 equals 37.5 equals 6F. Okay, so then I have to get this by itself. So I'm going to divide both sides by 6. So I have 37.5 divided by 5. Nope, not divided by 5. Let's try that again. 37.5 divided by 6 equals 6.25 equals F. Alright, so when I go back to my answer, I'm seeing that F equals 6.25. My answer here, all of my answer choices are in fractions, but I know it's 6 and 2, 5. I know that 6 and 25 cents is $0.25, so this is actually 6 and 1/4 equals F. Okay, but if I didn't know I could do that in my head that quickly, I knew it wasn't 5, and I knew it wasn't 2.5 because I came up with 6.25, which means it couldn't be 6 because I had 6 and then some, so I get rid of that. So this is my only viable answer, even if I didn't know how to convert 0.25 to a fraction of 1/4. Okay? All right, number 41. A person takes 720 breaths an hour. At this rate, how many breaths does a person take in 12 minutes? Okay, so I know that 1 hour is 60 minutes. Okay, so if I take 720 breaths in 60 minutes, it wants to know how many breaths do I take in 12 minutes. Okay, so I'm going to cross multiply, and that's going to give me 720 times 12 equals 8,640 equals 60B. Okay, so 8,640 divided by 60 equals 144. So B equals 144. I also could have done, how did I get from 60 to 12? Well, if I divided 60 by 12, I'd know it was dividing by 5, and so I could have divided 720 divided by 5, and I also would have gotten 144. So how many breaths does a person take in 12 minutes, 144 breaths. Okay. Number 42. Sean goes on a road trip in his car from Tampa to Gainesville. The distance between these two cities is 162.5 miles. It takes him 2.5 hours to drive to Gainesville. What's the average speed Sean is traveling? See, they're trying to trip us up by giving us decimals and fractions, but we're smarter than that. Because we know that 2.5 hours is 2.5. Okay? So I know he goes 162.5 miles in 2.5 hours. So I want to know, how many miles does he do in 1 hour? Okay? The other way I can do this, I can cross multiply, but this is going to be 1 and that's going to be that. So I can just divide 162.5 divided by 2.5. That's going to give me 65. Okay, so this is 65 miles per hour. I could have cross multiplied. If I did the cross multiply, I would have had 162 equals 2.5 m, and I would divide it by 2.5 and divide it by 2.5, which is exactly what this one says here. Okay? When I'm going from this to a unit rate, all I have to do is divide the numerator by the denominator. Okay? All right, so there's my answer for this one. He's going 65 miles an hour. All right. Pablo recorded the number of miles driven and the amount of gasoline used in the table below. At this rate, what's the maximum number of miles that can be driven with 12 gallons of gasoline? All right. So let's see, do we have a rule? Let's see, is 32 times 5, 160. Okay, so this is 32 times 5. This is 32 times 10. Let's just make sure it's all right. 32 times 15 is 480. Okay, so I know that this is my formula y equals kx. Okay, this is my y, and this is my x, and this is my k. So my distance, I'm looking for my distance, equals 32 times, he wants to know 12 gallons of gas, on 12 gallons of gas. So I'm going to plug into my calculator, 32 times 12, and that gives me 384. Y equals 384. So the maximum number of miles that can be driven with 12 gallons of gasoline is going to be 384 miles. Okay? All right. Number 44. The weatherman says a cold front's moving through the area. Hourly temperatures are shown in the table. Which of these statements correctly states the change in the number of how the change in the number of hours affects the change in the temperature? It says the temperature increases 3 every hour, it decreases 1 every 3 hours, it decreases 3 every 1 hour, or the temperature increases 1 every 3 hours. Well, I guess we need to go up here and figure out what our rule is. So from 7 to 8, that's 1 hour, and what happened? It went from 50 to 47, so that was minus 3. And we have another hour, and it went down from 47 to 44, that's another 3. And here it went down another 3. And here it went down another 3. Here it went down another 3. So every hour, it's going down 3 degrees, right? All right, so it's not increasing, so we know it's not that one. We know the temperature is going down, so it's not either one of those. I can cross those off. Is it increasing 1 degree every 3 hours? Nope. This is it right here. It's going down 3 degrees every hour. Ugh, that's still cold. It shouldn't be colder at noon than it was at 7 o'clock when you got up. This is why we live in Florida and not where it snows. Just saying. All right, number 45. The distance in miles of each of the 3 students from home is shown on the table. Okay, so which students are walking at a proportionally constant rate? Oy. Okay. So, at 8 o'clock they're at home. At 8:30 they've made it all the way to school. Okay, so this is 1, 2, 3, so it's in thirds. Okay. Okay, so if we take their distance and divide it by 3, 1.2, and divide that by 3. So I'm working on diphtheria at the bottom. That's 0.4 every 10 minutes. Oh, looky there. 0.4, 0.8, 0.2. She's going at a constant rate. Let's check out Divisio. He's 1 mile away. And he, divide that by 3. That's 0.33. Nope. That one's not. Because that would have to be 0.33, 0.66. Yep, that's not going to work. And what about Addie? She's 1.05 miles away, and if we divide that by 3, she should be going 0.35. And then 0.35 plus 0.35 is 0.7. And that, okay, so that works. So it's this one. So what students are walking at a proportionally constant rate? Addie is. Addie and diphtheria. Okay. All right. Number 46. Bobby earns money during the summer with a dog walking business. His earnings per number of hours worked are shown in the graph below. Okay. How much does Bobby earn per hour of dog walking? All right. Well, here's his earnings and here's his hours. We see that it's a proportional rate. So I'm just going to find my unit rate by going to my 1 and going up until it meets. And I'm going to mark it there. And so I can see that it's between the 4 and the 6, which tells me it's $5 per hour, which is C. All right, number 46. That was number 46. Haha, just kidding. Number 47. All right, the graph shows the number of calories you burn bike riding. The table shows the number of calories you burn when running. Which activity burns more calories per minute? Okay, more calories per minute. All right, so I'm going to look at this graph. So this is bike riding, and I know that they do 80 in 10 minutes. So if we do 80 in 10 minutes, that means we're doing 8 in 1 minute. Okay. 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 So then this is 136 and 16 minutes. If I take 136 and divide it by 16, I get 8.5. Let's try this one. 221 divided by 26, I get 8.5. Just want to double check them, make sure we're not doing something funky. 357 divided by 42. That also gives me 8.5. And I bet 442 divided by 52 is 8.5. Look at there. 8.5. So which activity burns more calories per minute? Well, I have 8 and 8.5. 8.5 is greater than 8, so running. Okay. All right, 48. 2 months ago, a bicycle shop sold 120 bicycles. Last month, 138 bicycles were sold. Find the percent increase of sales. All right, remember our thing for percent of change? You take the old and the new and subtract the two. Put it over the original. Make a fraction, boo. So we're going to take the old minus the new, put it over the original. Okay? So for number 48, we're going to take 138 minus 120. Okay? And that's all going to go over 120. Okay, so what's 138 minus 120? 138 minus 120 is 18. 18 divided by 120. 18 divided by 120 is 0.15, which equals a 15% increase. Okay, so I have a 15% increase. 15% increase. Okay. All right. 49 is also a percent of change problem. Okay. I have a suit that's $200. It's marked down to $160. And my original price was $200. So that's a $40 difference out of 200. So I'm going to take 40 divided by 200, and that gives me a 0.2. So that is a 20% markdown. Okay, 20% markdown. All right, number 50. Danica and Keisha both opened a savings account on the same day. Danica deposited $864 into her account, and Keisha deposited $253 into her account. After 6 months, Danica's account increased to $1,106, and Keisha's account increased to $329. What was the percent increase for each of the savings account over the past 6 months? And who made a greater percent of change? Oh, so many words. So many words. All right, let's break it down. We'll do Danica, and we'll do Keisha. Okay? Her start was $864. Her end, so this is Danica, 1106. Okay, Keisha, her start was $253. Her end was $329. Okay, so I have to find the difference between these. So I have to say 1106 minus 864 and put it over the original amount. Same thing over here. 329 minus 253. Put that over 253. Okay, so let's do Danica's first. So Danica has 1106 minus 864 equals 242 over 864. Okay, so that's 242 divided by 864, and that gives me 0.28. Oh, and some O's and stuff. So we're just going to go with 0.28. Alright, let's hop over here to Keisha. Okay, so she had $329, and she started with $253. So she winds up with $76. Okay, so we're going to divide 76 divided by 253, and that gives me 0.30. Okay, so this is 30%. This is 28%. Okay, so what was the percent increase for each savings account over the past 6 months? Okay, so Danica had a increase of 28%, and Keisha had an increase of 30%. So 30% is more than 28%, so Keisha's was greater. Keisha had a greater percent of return. Okay? Keisha made the greater percent of change. Alright, 51. Donna plans to use her put her graduation money in an account and leave it there for 4 years while she goes to college. She receives $850 in graduation money that she puts into an account that earns 5% interest annually. How much will be in Donna's account at the end of 4 years? Okay, do we remember what our formula for simple interest is? Remember, we have interest equals principal times rate times time. I equals PRT. Okay? So her interest, I'm going to do this one over here. Okay, so interest equals principal times rate times time. So I got to figure out what her interest is. Her principal is the $850. Okay, times the rate, which is 5%. I have to write that as a decimal, 0.05. Times how long? 4 years. Times 4. Alright, let's plug all that into our handy dandy calculator. So I have 850 times 0.05 times 4 equals 170. So her interest is 170. Okay, now, does that answer this question? This is what's going to be added to the $150 that she had. So her total equals principal plus interest. So her total equals her $850 plus the 170, and I plug it into my handy dandy calculator. 850 plus 170 equals 1020. So how much money will be in her account at the end of 4 years? $1,020. Okay, let's block this one off so it doesn't get confused with whatever we're doing here. All right, find the percent of change in population from 2000 to 2040. Okay, this is our projection. And predict what the population will be in 2050. Okay. All right, so in 2000, it was projected we were at 281 million, and it's projected that 2040 that will be at 372 million. Okay, so I have to take 372 minus 281 over 281. So I have 372 minus 281 equals 91 over 281. So 91 divided by 281 equals 0.3238. So we'll call it 0.324. We'll round it up to there, which is 32.4%. Okay, so 32.4%. So we want to do a percent of change is going to be, if my percent of change is 0.324, and that equals 372. Let's see. So it's going to be an increase. So I'm going to take 372 times 0.324. 372 times 0.324, and that equals 120.528. We're just going to round that to, we'll just say 121. So we're going to have 372 plus 121. 372 plus 121. 493 million. Okay, so we can make a prediction of 493 million. I don't know if that sounds right to me. I'm going to have to look at this one again. I may have to do another video on this one problem because that doesn't sound right to me. But for now, we'll go with it. And I don't think it's right. I don't think that's right. So if you can come up with the right answer before I come up with the right answer, 5 more gobbler dollars. All right. That is through number 52.